Hi everybody, let's try this another low-hanging fruit on Leetcodes today. It talks about reversing an integer. So given a 32-bit signed integer, reverse digits of an integer. So input is 123, output is 321. Let me just step out for a minute and close the door. Yeah, so the output is 321, for input is 123, and then when input is minus 123 and negative 123, we have output of negative 321. So the negative sign is preserved as it is, but basically we need to reverse the digits of an integer. Now let's see here. We have 120, example 3, and we are getting output of 21, which is because 0 would become the most significant digit. And then it says later on here in the problem, assume we are dealing with an environment which could only store integers within the 32-bit signed integer range. That means minus 2 raised to the power 31 to 2 raised to the power 31 minus 1. So if we have a number which is greater than 2 raised to the power 31, if there is a integer overflow, we have to basically pretty much return 0, is saying here. So let's start this problem. It sounds fairly easy. So let's start by having first a variable is negative, and is negative is set to true if x less than 0, else it's set to false. So that's our is negative. And now what we're gonna do is, strategy usually in these kind of reversing things is that you start by taking each digit in a loop. So you will start by taking the least significant digit, like in case of, in the example 123, you start by extracting 3 out and leaving 12 in. Then you extract 2 out, leaving 1 in, and that's how you basically go. So how do we extract the least significant digit from the number? So for that, what we can do is, let's have a accumulator where we would be storing our result. We say result equal to 0. Now if what we do is that we say remainder, and then there would be a, so what we can say is that every time we add tens of the digit or the hundreds of the digit, or every new 10 place, what we can do is, so for example, this one is 10 raised to the power 1 place. For example, if you take the number 123, if you will see that 3, this can be written as 1 multiplied by 10 raised to the power 2 plus 2 multiplied by 10 raised to the power 1 10 raised to the power 1, and then you have plus 3 multiplied by 10 raised to the power 0. So as you can see, as we go through the loop, we should be keep by having the 10 place, every number that we extract needs to be multiplied by its suitable tens power and then add it to the sum. So that's the idea. So we say result is equal to 0. So we start by while x, we say we take each digit. So we say remainder is equal to, let's try 10 raised to the power, we say x mod 10, and x is equal to, now why are we doing this 2? This is basically the Python's way of doing integer division. I think we talked about in one of the previous videos. So this is integer division. Now, so what would be our result at this point? Result would be 10 times result plus remainder, which is x mod 10. So we can probably take, we need not have this. So, and this we can move to the next as a logical flow. Now, so that basically gives us the, so we will start with the result being 0 first time around. We will see in case of 123 we'll get 3. Then we will go, and then x will become 12 because this is integer division. And then we'll get 2, and 2 would be added to the previous 3. So that's basically 2 times result at that point would be the previous value, which was 3. So if you take so 2 would be added to the previous result, which is in the first iteration of the loop we had 3. We had, so the result was 3, so 3, and then we basically multiply the previous result with, so that is 30 plus 2, so it will become 32. That kind of makes sense, right? We're going in the right direction because ultimately we want 321. And the third iteration of the loop, it will get multiplied by 10 again. So every time you go through the loop, you keep multiplying by 10, and that way you're making sure that every digit is multiplied by its 10 raised to the power. So at the end of it, when we have x equal to 1, because in the next iteration will be 12 by 10, 1, so it will still go inside and it will end up being 321. And when you do 1 by 10 again integer division, you'll end up with 0, and then this loop will start. So basically that should give us the result. Only thing we need to make sure is that if the result is, here is asking us that the function is 0 when the reverse integer flow overflows. So if result is greater than 2 raised to 31 minus 1, then we can say that we will return 0. So that's basically return 0, and then we need to also take care of the fact that if it is negative, so if is negative, then we basically say result is equal to else, or we can actually write in a more Pythonic way, return result, we can say return result if not is negative, meaning if it is, if return result if is negative. Okay, good. So if is negative, if true, if oh no, so if not is negative, else minus result. How about this? So we start by saying that if return result if not is negative, and if is negative is false, then we return, if is negative is basically true, so this becomes false, else we return minus result. Let's see if it runs. Seems to be working fine. Now see if, I just have a little bit doubt here if our logic on line 12 is correct. So we started by saying is negative equal to true if x less than 0, else we said it is false. And now here we are saying if is negative, if we will return result if is negative, if not is negative. So yes, and else we will return minus result. So that looks good. So let's try to do some math and see if it passes all the test cases. Time limit exceeded. So what's going on here? Have we run into some kind of infinite loop or something? We did do a here x equal to x by 12. So while x, oh, I see what is happening here. You know what? When the last thing happens like 1, when x becomes 1, we say it keeps being the, okay, I see. So it was looking good, but I think we have made a mistake here. Result, if you say x mod 10, if x mod 10 returns you 0, so we should have continued as long as remainder is this integer division changing x to x by 10. Does it cause x to never become 0? You say while x is, while remainder maybe would have been a better idea, because remainder would be 1, and if you say integer division, really, does it really cause the integer division here x equal to s by 10 as it become 0? What is the mistake are we making here? So x equal to x, this integer division, doesn't it make it to 0? I'm wondering why that is having an issue. So while x, now if you do 1 and then do integer division, what do we get? We should get 0, right? 1 mod 10 is 1, but 1 integer division 10 should be 0. So I'm wondering why should we have to do like while x greater than 0, or does that make more sense? Let's see. Oh, I see what is happening. You know the problem, I think I got it. What is happening is that if when the input is negative, we should also, and if is negative, then you know what we need to do is, if is negative, then we need to say x equal to minus x, because you know what would happen is that that without that we'll continue to work on a negative number, and which is not a good thing here. So basically we need to keep track of the sign, but on the other hand we have to work on the positive number here. So if it's negative, then x equal to minus x, and I think that should take care of it. Let's say submit. Lo and behold, we have basically passed here. So we made couple of mistakes on the way, like for example we forgot to work only on the positive number, basically turning the sign when we should have seen that it is negative. We didn't do that on line 4 and 5, they were missing. Here it's okay. I was confused about x equal to x slash 10 integer division. I was basically confused here, this is whether I would actually end up being getting 0 in the end, because my loop depends on eventually hitting 0, otherwise this loop will never stop. So, and here if result is greater than, I think that's about the overflow, and that seems to be good as well. And here we are saying if the number was negative, then we need to have the negative sign back on the number. So it's all looking good, and I think next time around we can see saying next challenge is over here. It's talking about a string to integer, a to I, and also the reverse bits, which I would have thought is more doable better in languages like C, but I guess you could do that in Python as well. So next time we might try to do that in Python, but that might be interesting exercise. Well, until then, have a good time coding, and debugging is always a challenge. So those interesting times when debugging becomes fun, I wish you all the best for those times. And until then, I will see you guys in the next video. Take care. Bye bye.